So we're going to review today. We're going to review tomorrow, or next time I see you, not tomorrow, but whatever that next day is. And then it'll be test time. And some of you are in need of a good grade, so I hope that you're taking advantage of all this review that we're doing. On the test, you will have access. I will have a sheet for you that will have the U plus V and half angle and all those formulas on it. These will not be there. Those need to be memorized. If you don't know that the cosine is the reciprocal of the secant, you're in trouble, right? That has to be memorized. But I'll give you these guys right here. Okay? All right, so who's got a question about one of the papers that I turned back? Kylie.
Letters on the back of the
Candy paper. All right, so she wants to see how to do, this was on her quiz, and she needs to verify this. The test will be just like this. I'll give you a couple and so I'll give you 4, I think, and you'll pick 2 or 3, I'm not sure what we decided on. All right, so here we go. What would make sense? Oh, first of all, this is nothing. Some of you changed this into a cosecant. What's missing? It's not squared. Those identities don't work unless it is squared. So that is nothing. You cannot change that into anything. Those Pythagorean identities are squared. Okay, so what can I do? Can't do that. What can I do? Change them into sines and cosines. And that makes sense, because isn't that what I'm trying to end up with over here? So I'm going to change that into cosine over sine. And I'll change this into sine over cosine. Now you need to have those memorized. You need to know those. Those are easy. Now we've got a real mess. My preferred method of cleaning this up, and I don't care how you do it. You can get a common denominator on the top, get a common denominator on the bottom, and invert and multiply. That will work fine. I prefer just to look at the whole thing and say, okay, the common denominator of the whole thing is sine cosine. So I'm going to multiply everything by sine cosine. Now the reason I'm doing this is, it is going to cancel these denominators. So now I still have a big fraction, but it's one numerator and one denominator. It's not all this done. So sine cosine plus cosine squared over sine cosine plus sine squared. Now some of you are thinking, oh my gosh, Mrs. Ford, that was worse than it did to start with. Well, it's certainly bigger. But can I do anything to shrink it down? In other words, can I factor it so that I can do some canceling? Is there any factoring that can happen on the top? Take out a cosine. And that'll leave me with sine plus cosine. Okay, what about the bottom? Can I take anything out of the bottom? Sine. And that'll leave me with cosine plus sine. Now, at this point, nothing can cancel. Because the only way you can cancel when you have additions or subtractions is if you can cancel the whole shebang. Well, you can't here. These don't match. So there's no canceling that can happen here. But, can I cancel these? Yes, because I'm not canceling a piece of the addition. I'm canceling the whole thing out. You cannot cancel pieces of an addition or subtraction. But if you can get the whole whole thing to match, you can cancel out what am I left with? What I wanted. Yep. What I wanted. All right, anybody else have a question about anything that I handed back? We're gonna look at the pretest in a moment, but anything that I handed back. Yep, Grace.
Can you do number 3 from the quiz?
Did you have 2 tan x sine x
Yeah.
minus tan x equals 0? And the directions say from 0 to 360, which tells me that I'm solving in degrees. Right? All right, so let's look at it. What can we do with that? We can factor out a tangent. So tangent comes out, and I would be left with 2 sine minus 1. Patrick, you need to see the nurse? Can you get a better lawyer tonight?
Yeah.
Okay. What do I do once I factor in an equation like this? Once I factor, I set it equal to 0. So tan equals 0, or sine equals 1/2. Now zeros are those problematic things where I can't really draw a triangle, I have to look at my circle, right? So where on the circle will the tangent be 0? And again, you can't draw a triangle because tangent is opposite over adjacent. And the opposite can't be 0. A side can't be 0. So I've got to look at my circle. And somewhere around here, y over x is 0. Well, where is y over x 0? Here and here. Yep, that's where it's 0. So the answers to this piece are 0 and 180. Now, where is the sign a positive number? Some of you are skipping this step. You're jumping straight to the 1/2. And that's okay, but there's 2 of them. There's 2 places where the sign is positive. Where is the sign positive? 1 and 2. And we know that because sine is y, and y is positive up here. So if the sine is 1/2, then how big is this angle? 30? And a lot of you got 30, which is really good, but a lot of you also didn't get the other one, which is 150. So we have 30 and 150 are also answers to this problem. Okay, Grace? All right. Lillian,
Can you do number 2 on the quiz?
find the cosine of 105. Well, what do I do? What do I have to do first?
You split it up into 6.
I gotta split it up into something. So you split it up into 60 and 45, which makes perfectly good sense to me. Cosine 105 is cosine 60 plus 45. Perfect. You can do 45 plus 60. It does not make one bit of difference. All right, then I need my formula for the cosine of u plus v. So cosine 60, cosine 45, minus sine 60, sine 45. Straight off the paper. That's it. That's the formula. So now I need to figure out what all these numbers are. So I'll draw my 45 over here to the side. And I'll draw my 60 over here to the side. You gotta have that memorized, okay? Or, I mean, the 30, 60, 90 thing memorized. You don't have to have memorized the cosine of 60, but you need to be able to figure it out. The cosine of 60 is 1/2. And the cosine of 45 is 1 over root 2, or root 2 over 2. The sine of 60 is root 3 over 2. And the sine of 45 is also root 2 over 2. Now, some of you got these numbers mixed up. Some of you put negatives on them. And that I don't understand at all. Aren't both of these in quadrant 1? If you use 60 and 45, there are no negatives in there anywhere. All right, now when I multiply these, I get root 2 over 4. Top times top, bottom times bottom. And root 6 over 4. These do not subtract. You cannot do anything with that, but you can write it as a single fraction since the denominators match. Okay? Anything else before we go to the pretest? This is another verification. So, secant squared minus 1 over sine equals sine over 1 minus sine squared. Okay? I would probably start over here because those are all sines, so I'll just start over here. And secant squared minus 1 rings a bell to me. What is secant squared minus 1? Let's see, 1 plus tangent squared is secant squared. So isn't this tangent squared? And tangent squared would be sine squared over cosine squared over sine. Which is a complex fraction. So multiplying top and bottom by cosine squared, I get sine squared over cosine squared sine. So that's where I am right now. That's where I want to be. I can cancel this out, right? So now I have my sine, but it's over cosine squared. But what's cosine squared? One minus sine squared. Because sine squared plus cosine squared is 1. So you can change that. Okay, what else? That's it for that? All right, let's put all those papers away then. And let's get out our pretest again. And we were about to do problem 2 when we ran out of time. And I want to make sure I get to every kind of problem. So I'm not probably going to do every single one unless I have extra time at the end. But we'll do this first one. We've already done some verifying today. Boy, I hate to do it because I've got the same functions on both sides, but I really don't see anything to do except changing the sines and cosines. So this would be cosine squared over sine squared. And this is cosine squared over 1. So if I want to put those together, and stop and think about this for a second, guys. Don't I need to put them together? Is there any plus sign in here? No, this is all one term. That's two terms. That's one. I gotta get a common denominator and put them together and then hope good things happen. So common denominator will be sine squared. So I have sine squared on the bottom. And then I have cosine squared minus cosine squared sine squared on the top. Now I still have a minus sign in there. Is there anything you can see I can do now? Please don't tell me to cancel. You cannot cancel part of a subtraction. The only way to cancel would be to factor. Can I factor?
Yes.
What can I do?
Take out a cosine squared.
I can take out a cosine squared. And when I do, I will be left with 1 minus sine squared. Wait a second. What's 1 minus sine squared?
Sine squared.
1 minus sine squared is cosine squared. Is that what you said? So I have cosine squared times cosine squared over sine squared. Well, that's good news because now the minus is gone. And what is this right here? Isn't that cotangent squared? Now keep in mind, this fraction right here is cosine squared over 1 times cosine squared over sine squared. You're allowed to think of it like that. Because when you're multiplying, isn't it top times top and bottom times bottom? So you're allowed to think of it like that, and that's what we wanted. That's cosine squared times cotangent squared. Now, on test day, you may or may not be able to get all the way to the end of the problem, but do something, right? Change into sines and cosines, get a common denominator, do something, factor if you can, so that you get at least an opportunity for some points, even if you can't get the whole thing done. All right, let's do one more from that section. I don't care, B, C, or D.
C.
C? Well, this is kind of the same thing because we've got two terms over here and only one over here. So somehow we have to put those together. What occurs to you when you look at this? This is what you have, this is what you want. What occurs to you? Yeah, this is 1 over sine, and this is 1 over cosine. Don't you want sines and cosines? Well, now what do we have? Two fractions. So our common denominator will be cosine sine. So this one has to be multiplied by cosine. This one has to be multiplied by sine, so that they now are the same denominator. What's the numerator? Well, that one is cosine, and that one is sine, and oh my gosh, we're done, aren't we? So if you let yourself be frightened of the problem, you're missing out on opportunity. That one was pretty cut and dry. Change into sines and cosines, get a common denominator, add them together. Done. If we have time, we'll come back and do the other two, but I wanna make sure we hit on every kind of problem. So let's look at number 3A.
This one,
Yes,
you,
yeah. Tell brother he owes me.
alright.
All right, so here we go. Sine, I'm doing the first one there. My directions are sine 2x equals cosine x. Okay, tell me what to do. You guys know this. You know what to do. We just practiced this not long ago. What do we do?
Subtract cosine.
All right, so I gotta get the cosine x over on the other side.
And factor.
Can I factor? Yeah, I'm going to factor, but not now because there isn't anything to factor, right? But what do we know about sine 2x?
Equals 1 minus cosine.
Sine squared is 1 minus cosine squared. This is not sine squared, this is sine 2x. It's on your sheet, kids. The answer is always on your sheet. Sine 2x is 2 sine cosine. Now, Sophia, now I can cancel. Or factor, I mean factor. Because when I change this into what it is, 2 sine cosine, now I can take out a cosine. And what will I be left with? 2 sine minus 1. Set an equal to each, or set an equal to 0, so cosine equals 0, or sine equals 1/2. This is a lot like the one we did earlier, except this is a cosine is 0. Where is the cosine 0? As we go around our circle, cosine is x. Where is x 0? At 90 and 270. So these answers are 90 and 270.
Would it have to be in radians?
Oh shoot, yes, I wasn't paying attention to my directions. Thank you. So, not 90 and 270. What are my radian measures for 90 and 270? Pi over 2 and? Yep, thank you very much. Now, where is the sine 1/2? Well, we actually just did that in another problem, except, like Abby said, this was gonna be in radians. But that doesn't change the location. Remember, there are 2 places that the sine is positive. Sine is y, and y is positive up here. So what kind of an angle looks like this? 30. If I'm in degrees, it's a 30. In radians, 30 is a 1/6 of 180. So this is pi over 6. And so is this. So my answers are pi over 6. And what would this one be? All the way around to there, what would that be? 5 pi over 6. Perfect. 1 pi minus a 6. 1 minus a 6. 5, 6. There you go. So, what was the first thing we did on that problem, you guys? Well, we changed sine 2x, right? We gotta change sine 2x. Now, look at problem B. Problem B is going to be a calculator problem. I didn't denote on here, but that will be a calculator problem. You'll see why in a second. And this time I am in degrees. So I want to make sure my calculator is set in degrees. when I get to that point. What am I gonna do with that? Notice there's no 2x. Like, this problem had a 2x, so I changed it using my formula sheet. This one doesn't have that. But I still want to factor it. Can you see how this one factors? It's a quadratic, guys. It's going to factor tan minus 5 and tan plus 1. It's going to factor just like the first year algebra problems factored. Foil it out. See how I got the -5? When you add these, you get -4, right? So this says tangent equals 5, and tangent equals -1. Now, this one I can actually do without a calculator. So we'll do this one without, and we'll do this one with. The answer will be the same. I mean, with or without, the answer is the answer. Where's the tangent negative? Tangent is y over x. Opposite over adjacent. Where does that turn out negative? 2 and 4. Tangent's negative in 2 and 4. Because consider x and y. One's positive and one's negative here. One's positive and one's negative here. So when you put one over the other, you're going to end up negative. And if it's 1, how big is the angle? 45. So what are the answers to this problem right here? Well, this would be one of them. What is that? 135. And this would be the other one. It is 315. So 180 minus 45 and 360 minus 45. That takes care of this. Now, do you understand why I need a calculator on this one? No, the tangent can. The tangent's positive, so it's going to be here or here, but my numbers are 5 and 1. Do I know that angle with a 5 and a 1? No, that's what I need my calculator for. So I'll do second, first of all, I'm going to make sure I'm in degrees, I am. And then I'll do second tangent 5. Does that make sense to everybody, that I would second tangent 5? And I get 78.69. So certainly the first quadrant angle is 78.69. How will I find this third quadrant angle? What will I have to do? Add 180. So 180 plus 78, 258.69. All right, let's skip down to number 4. Again, we'll come back and do as many as we have time for. We don't have that many more to go, so we'll probably come back to them. But number 4, since you have your formula sheet, there is absolutely no reason for you to miss anything in this part 4. Look on your formula sheet. Where do you see cosine squared minus sine squared? Cosine squared minus sine squared. Where do you see it? Cosine of the double angle. Well, what is our angle in this problem? It's not a theta. What is our angle? 190. So this is the cosine of 380. That's it. That's all there is to it. That's all you have to do. So look on your sheet. Where do you see a radical with 1 minus cosine over 1 plus cosine? It's the tangent of the angle divided by 2. What's our angle in the problem? 122. So this is a formula for the tangent of 61. 2 sine cosine? Well, we used that one earlier. What's 2 sine cosine? Sine 2 times the angle. And the angle in this case is 111, so this is a formula for the sine of 222. Sine cosine minus cosine sine. Sine cosine minus cosine sine.
98 minus 12.
This is the form, not just the numbers. It's the formula for the sine of an angle minus an angle. And the angles are 98 and 12. So this is a formula for the sine of, what is that, 86? Sine squared plus cosine squared. Always and forever. Sine squared plus cosine squared is 1. So the answer to E is 1. It doesn't matter what the angle is. If you got sine squared and cosine squared, it's 1. What about F? Tan plus tan over 1 minus tan tan. That's the tangent, and you're adding the 2 angles. And the 2 angles are 53 and 91. So this is the tangent of 144.
And so for number 4E.
It's 1. Sine squared plus cosine squared is 1. Always and forever. Okay? Doesn't matter what the angle is. Those could be 37s, those could be root 2s. It doesn't matter. Sine squared plus cosine squared is 1. All right, 5 is a little proof, kind of like an identity, but it uses your formulas. So let's do it. Cosine 180 minus x. This equal this. All right, so what can I do with this over here? Cosine 180 minus x. What can I do with that? Use my formula. U minus v. So the formula says cosine of the first, cosine of the second, plus sine of the first, sine of the second. Cosine u minus v. Here's 180, right? What point is that over here at 180? Negative 1, 0. And cosine is x, and sine is y on the unit circle. So cosine 180 is negative 1, and sine 180 is 0. Well, what does that simplify to? Negative cosine, yeah. Which is exactly what we hoped would happen.
What happened to the equal cosine?
I was trying to make this equal that. This isn't a solve, this is a proof. So I did it. Right? All right, and the last one, we can do both of these. Cosine 75, we've actually already done something close to this. What is the cosine of 75? What am I going to do with that? It says find the exact. What's 75? I would do 45 plus 30. You could also do 1/2 of 150, but I think that's harder. So my preference would be 45 plus 30, but you could do the other if you wanted to. Then I'm gonna apply my formula, which is the cosine of u plus v. So that's cosine of the first, cosine of the second, minus sine of the first, sine of the second, straight off my sheet. My u is 45, my v is 30. They could be switched, wouldn't hurt anything. Now what do? I gotta plug in these numbers, right? So maybe you've got some of them memorized, maybe you don't, doesn't matter, you gotta figure them out. So what do we know about the cosine of 45? Root 2 over 2. And that was kind of easy to memorize because isn't the sine the same thing? Cosine and sine are the same for 45. And then 30, what's the cosine of 30? Root 3 over 2. And the sine of 30 is 1/2. So again, this is a multiplication problem. So it's root 6 over 4 minus root 2 over 4, which we can combine, but not totally combine. Root 6 minus root 2 over 4. Do not do anything with those radicals, you can't. All right, and then the last one, we'll go back and pick up some others if you want, but this last one we need to do, it says the secant is -5/3, and it's in quadrant 2. And we're gonna find the tangent of 2a. Now, I don't know what a is. All I know is that it's in quadrant 2. So I could draw a picture of it. It's an angle in quadrant 2, tells me in the problem. What do I know about these sides? Of the triangle here. Hypotenuse is 5, not negative. Hypotenuse is never negative. And the adjacent's -3, because secant is reciprocal of cosine. Can I go ahead and find that missing side? What does the Pythagorean theorem tell me about the missing side? Square root of 16, which would be 4. And it's positive because it's going up. So that's a picture of A. Now what about a formula for tan 2A? What's my formula for the tangent of 2A? 2 tan
x over 1 minus tan squared.
Yep, there it is. So guess what I'm gonna do? I'm gonna look at my picture and I'm gonna say, oh, the tangent is -4/3. And I'm gonna plug that number in right here. So 2 times -4/3 over 1 minus -4/3 squared. Now be careful of your arithmetic. What's 2 over 1 times -4/3? -8/3. And then be really careful down here. See these two negatives? They do not cancel because this one gets squared out. So it's 1 minus 16/9. Donovan, do you need to go see the nurse?
No, that's good.
Huh?
No.
pull your things out of your ears. And then sit up straight in your chair. And pretend I'm the most interesting person in the world for the next 20 minutes, okay? Now, again, it is up to you how you clean that up. You can do whatever you want. I'm gonna multiply everything by 9 because that's what's easiest for me. That is not what's easiest for you. It's fine, do your own thing. When I multiply by 9, my numerator becomes -24. And my denominator becomes 9 minus 16. So I have -24 over -7, which is 24 sevenths. So the final answer is 24 sevenths. That's what you should get. However you do the problem, when you simplify here, that's what you should end up with. Nope, you get a calculator for one part of the test, but not this part. Is it an emergency? All right, hurry up, leave your phone here. All right, so now I can't remember what we didn't do. I know we didn't do 3C, so let's grab that one. And then I think there's 1 or 2, and number 2 we didn't do either. We'll have plenty of time. So let's get 3C done. It's another equation to solve. And it's in radians, which is fine. I don't need my calculator for this problem, so that's okay. I'll just answer in radians. Okay, we've done one just like this already today. Tell me what I do first. Change the cosine 2x. Now, this is where things get a little tricky. Cosine 2x, look at your paper. Aren't there multiple versions of it? Right? Any one of them will work, but one of them will make your life easier. Abby? Yes, and Abby, what is your logic? Because there's already a sign in the problem. So Abby's saying, why would I use the other versions? Because that would just put cosines into the problem, and I gotta deal with that. So this is gonna make it the easiest. Now, I got a thing, I'm always being kind of critical of you guys when you can't factor. I got a thing from when I was like in 8th grade or whatever. I cannot factor this when that's negative. So I'm gonna move everything to the other side of the equation. You do not need to do this, that's a Lisa Ford thing, but I have to. So I'm gonna add 2 sine squared. Now my sine squared is positive. Subtract the sine and subtract the 1. Now I can factor it. Now it's in the right order for me to factor it. Do you see a quadratic there? So now I can factor it. So I have 2 sine minus 1 plus 1, I think. Let me double check that. And when I say double check, I'm foiling it. I'm foiling it to make sure it gives me what I started with, and it does. If you're not sure, foil it. Setting them equal to 0, what do I have? I have sine equals -1/2 and sine equals 1. Well, I had what I need on the board, but now I have to draw it again. Where is the sign negative? Start there. Where is the sign negative? 3 and 4. We know it's negative in 3 and 4 because sine is y, and y is negative down there. And it's -1/2. So how big is that little reference angle there? If that's a 1 and that's a 2 and this was supposed to be √3, how big is that angle? 30. But I'm in radians, so 30 is a sixth of 180. So it's gonna be pi over 6. They're both pi over 6. So now, how big is the blue angle? Pi plus pi over 6? 7/6 pi. And then how big is the red angle? Excuse me, 11 pi over 6, because it's 2 pi minus a sixth. Where's the sine 1? Don't I have to look at my circle for that? Think about that for a minute. If you tried to draw a triangle, wouldn't opposite and opposite and hypotenuse have to match? And they can't. So we can't draw a triangle. Where's the sine 1? No, 90. Right here. This is the only place the sine is 1. Sine is y. The only place is straight up, which is how many radians? Pi over 2. All right, we got a couple more to finish, and then I'll be still. I can't even remember now. We have 2B, but we haven't done 2B yet. So we'll do 2B. And as I copy it down, I'm going to go ahead and change cotangent into cosine over sine, and tangent into sine over cosine. All right, so when I wrote down my problem, this is 2B, I changed the cotangent into cosine over sine, and I changed the tangent into sine over cosine. I just saved myself some writing. Now, this is a distribute problem. So you're going to take sine times this and sine times this. Well, what happens when you take sine times this first one? They cancel and you're just left with cosine. Now, when you take sine times this one, you get sine squared, right? But what happens to these guys? Don't they cancel on their own? There we go. That is one dedicated student. Coming back for the last 12 minutes. I think I love you, Alexis Mattingly.
Oh, thank you.
All right, and then D, last one, problem D. All right, somebody tell me, what is your thought on this one? Pretend this is a test question, and you have to do it. Gabe Jones, you got any ideas? No ideas at all. Okay, so think about some of the things I've suggested to you to get started. I heard somebody say it over here. Change in the sines and the cosines. Now, kids, there are 2 reasons for that. One is you need something to do, and that's always an option when you've got tangents and secants, and cotangents and cosecants. You can change them into sines and cosines. But another reason to do it is, look at what you want to end up with. There's no tangents over here. So let's make this sines and cosines. So this is sine over cosine, and this is 1 over cosine. Well, it doesn't get much better than that. We have a common denominator. So sine plus 1 over cosine. Well, I guess it could be better than this. That is not what I wanted, right? I got started, but this is not what I wanted. We did a problem like this a while ago, it's been a long time ago, when we first started doing this. Anybody remember what we might do, Alexis?
Multiply by the reciprocal?
By the conjugate or something, you mean? Yeah. Well, I can't just, whatever I multiply by, I have to do the same thing to the top and the bottom. So, what do you want to multiply by? Just tell me and I'll do it. Because as long as I do it to the top and bottom, it's all good.
The sine x plus 1.
So you want to multiply top and bottom by sine x minus 1?
Yeah.
You know what? I'm going to multiply by 1 minus sine x, top and bottom. Because, Alexis, I'm allowed to multiply by whatever I want. And isn't that what I want in the bottom? Now, would sine x minus 1 work? Yes, but I'd have an extra step at the end to get it turned back around. So I'm going to go ahead and just do it right from the beginning. Now, on the bottom, I'm just going to leave it. And now on the top, I'm going to FOIL. So foiling, F-O-I-L. Sine plus 1 minus sine squared minus sine. I just FOILed those two parentheses together. What's left? So what do I have?
1 minus sine x.
1 minus sine squared. Now, please do not cancel. These are not the same, so they don't cancel. But what do I know about 1 minus sine squared?
It's equal to cosine squared.
It's equal to cosine squared. Now I can cancel a cosine. And look what I'm left with, exactly what I wanted. Now, that problem took a little bit of trickiness. Alexis knew what to do. She multiplied top and bottom by 1 minus sine. You could also have multiplied top and bottom by cosine, just cosine. You are allowed to multiply by whatever you want. And multiplying by cosine would make sense because you need a cosine up top. And now you would have it. But then you'd have cosine squared, which you'd have to change into 1 minus sine squared, factor, and cancel. So that problem was tricky because I had to actually insert something new into the problem. You can insert whatever you want as long as you're doing the same thing to the top and the bottom. Okay? Now, what's going to happen next